discuss about the intraoral radiographic machine. The intraoral radiographic machine is the one which we use in our routine dental practice to visualize the teeth and the adjacent structures. So we discuss in detail about the parts of the intraoral radiographic machine. So first of all, it is made up of three components, that is the control panel, the extension arm and the tube head. So you have the control panel. This is the control panel wherein you have the switches for the adjustment of the exposure parameters and switching on the X-ray machine, etc. Then you have the extension arm which connects the control panel with the X-ray tube head, and then you have the tube head. There are several dental X-ray sets available from different manufacturers. They are more or less similar. Now discussing about the parts of the X-ray machine. We already mentioned that it has three parts: control panel, extension arm and the tube head. Now in detail we have to discuss about the parts of the tube head. The tube head, the parts are divided into two. It is parts that are seen externally and those that are seen internally. Now the parts that are seen externally include the metal housing of the tube head, position indicating device and the angle meter to adjust the vertical angulation. The parts that are seen internally include the insulating oil, the X-ray tube proper, filter, collimator and the transformer. The X-ray tube proper is again divided into cathode, anode, which is enveloped in a glass house. The cathode is made up of filament and focusing cup, whereas the anode is made up of the target, that is the tungsten target embedded in copper stem. Now first about the control panel. The control panel consists of the main on-off switch and the warning lights, an exposure button, a digital time indicator, switch to increase or decrease the exposure time, an exposure time setter, and a warning light and audible signal to indicate when X-rays are being generated. The extension arm connects the control panel to the tube head, and it holds the X-ray tube head and houses the electrical wires. They support the tube head either by direct connection or with the help of a yoke. Now this is the pictorial representation of the X-ray tube, wherein you have the anode, cathode, the glass envelope, you have the step-up transformer and the step-down transformer, you have the metal housing, you have the lead collimator, the aluminium disc which acts as the filter, and you have the position indicating device. The tube head is made up of metal housing externally and it is connected with the position indicating device. Metal housing is the external body of the tube head made up of metal which is tightly sealed and filled with oil. Internally contains the X-ray tube, transformer, filter, etc. Position indicating device is also called as the core. It is connected to the tube head and it is made up of lead or plastic. It is of two lengths, that is the short cone and the long cone. Short cone is about 8 inches and the long cone is about 16 inches. But it is also classified based on the shape. You have a conical position indicating device, a rectangular one and a round one. The main function, as you know, the X-ray beam is a divergent beam. So the function of this position indicating device is to shape the X-ray beam and prevent the over divergence. Angle meter is present on either side of the metal housing with a hinge joint for the vertical movement of the tube head. It consists of markings of different angles from 0 to 80 degree in either direction. It is to guide the accurate vertical angulation while taking radiographs. Insulating oil surrounds the X-ray tube and transformer. It acts as an insulator to prevent the overheating of the X-ray machine by absorbing the heat that is generated during the production of X-rays. An X-ray tube is the most important component of the X-ray machine. It is mainly composed of the leaded glass housing, the cathode and the anode. The leaded glass housing acts as an envelope. It is made up of borosilicate glass along with lead. It is completely evacuated inside to prevent the ionization of air inside the tube. What happens when there is ionization of air inside the tube? It will decrease the speed of electrons, and as a result, the efficiency of the machine will be reduced. It is kept unleaded in the central area, which acts as a window for the exit of the X-rays from the glass house. Mainly, it prevents the radiation leakage. That is, it prevents X-rays from escaping in all directions. Other than this X-rays will only escape through this unleaded central area. This is the parts of the X-ray tube. You have the cathode, which is the tungsten filament embedded in the focusing with a focusing cup made up of molybdenum. You have a target tungsten, which is embedded in a copper stem. This is the unleaded glass window through which the X-rays exit the X-ray tube. Cathode is negatively charged. It is composed of the focusing cup and the filament. The main function of the cathode is to generate electrons and to focus it to the anode. Cathode is made up of tungsten. It is having a thickness of 0.1 to 0.2 millimeters with a length of 7 to 15 millimeters and a diameter of 1 to 2 millimeters. The main function of the cathode is to emit electrons. This emission of electrons is by the process of thermionic emission. Thermionic meaning heat. That is, when the filament is heated to incandescence, it will generate the electron. The focusing cup is made up of molybdenum and nickel, and the melting point of it is 2620 degrees Celsius. The main function is to focus the electrons that are generated at the cathode towards the anode. Anode is positively charged. It is composed of a tungsten target that is embedded in a copper stem, and main function is to generate the X-ray. The main function of the copper stem is to dissipate the heat that is being produced at the tungsten target. Now, this target can be of two types. That is, the anode can be of two types. It can either be a stationary anode or can be a rotatory anode. Now, the main advantage of using a rotatory anode is that there is a dissipation of heat when compared to stationary anode, because the target will get additional time to cool because of the continuous rotation of the anode. Now, this target is always inclined at a 20-degree angulation to the central X-ray. Why? Because to decrease the amount of heat production and to increase the sharpness of the image. That is, main function of this tungsten target is to convert the kinetic energy of the electron into X-ray photons. The point at which the X-rays hit the target, that is the center area or the heart of the target, is called as the focal spot. Now, this target is embedded in a copper stem. Why? Because this copper has a high thermal conductivity and it dissipates the heat, and it will reduce the chance of melting of the target. Now, why tungsten is chosen as the target material? Mainly due to four reasons. It has a high atomic number, so it will cause more protons and high binding energy of the orbital electrons. So high charge will cause greater deceleration of the bombarding of the electrons and more conversion of more kinetic energy into X-rays. High melting point would prevent the melting of the target even at high temperature. High thermal conductivity, it will dissipate the heat by conducting the heat to the copper, and low vapor pressure will maintain the vacuum at high pressure temperature. Now there are transformers which help to increase or decrease the voltage in an electric circuit. That is a step-up transformer and the step-down transformer. You have an auto transformer also. Step-up transformer, as the name indicates, is to increase the voltage, whereas step-down is to decrease the voltage. Now, what is a focal spot? The focal spot is the area on the target to which the focusing cup directs the electrons from the filament. Now, how sharp your image is depends on the size of the focal spot. Now, as the focal spot size increases, the sharpness reduces. As unsharp, so the ideal size of a focal spot is 0.6 to 1.2. So the main idea behind this is that you should keep the focal spot size as small as possible. Now, what is a disadvantage in keeping a small focal spot size? The heat generated per target area will be very high. So that is a disadvantage. So in order to make the image sharp and to cause the increased dissipation of heat, we have decided the machine has been made in such a way that the target is inclined at 20-degree angulation to the central X-ray. So what happens? The effective focal spot becomes as almost as 1 into 1 mm, whereas the actual focal spot size is 1 into 3 mm. This is called as the line focus principle, and this 20-degree angulation is called as the angle of truncation. Next is the filter. X-ray is having multiple wavelength or multiple energy. Some are of low energy, some are of high energy. Now, this low energy X-rays do not contribute to image formation. They just penetrate the soft tissues and cause harm to the patient. So, filter is placed inside the X-ray machine so that we can remove the low energy X-rays, thereby decreasing the patient exposure with no loss of radiographic information. Mainly, there are 3 types of filtration: inherent filtration, added filtration, and total filtration. Inherent filtration are the inbuilt components of the tube. That is, right from the focal spot till the exit of the X-ray from the tube head. Inherent filtration should be equivalent to 0.5 to 1 mm of aluminum. Whereas added or external filtration includes aluminum discs placed over the exit port of the tube heads. It is around 1 to 1.5 millimeters of aluminum. Total filtration includes the sum of the inherent and the added. For a machine of 70 kVp, around 1.5 millimeters of aluminum filter must be used, and machines greater than 70 kVp, around 2.5 millimeters of aluminum should be used. Next, you have the collimator. Collimator is a method, is the machine that is used to control the size and the shape of the X-ray beam. Collimator is actually a metallic barrier with a window that is used to reduce the size of the X-ray beam. It is made up of lead. If collimator is not used, X-ray beam will diverge in a broad base and it will expose the more body surface area, which is undesired, and which will increase the patient exposure and produce harmful effects to the patient. Mainly, it controls the size and the shape of the beam, thereby decreasing the patient exposure. Also, by limiting the size of the X-ray beam, we can also improve the image quality by reducing the scattered radiation. Ideally, collimator should be, for an IOPA film, collimator should be a 7 centimeter round collimator. There are collimators are available in different shapes, of which rectangular collimator is better than the round collimator. These are the different types of collimators: diaphragm collimators, tubular collimators, rectangular collimators, and slit collimators. It is classified based on the shape. These are the diagrams of the diaphragm collimator, slit collimator, tubular collimator, and rectangular collimator. So this is about the about the parts of the X-ray machine, which is very important, and this basic parts include the X-ray tube, control panel, and the extension, of which the X-ray tube, you have the detailed parts which include the cathode, anode, as well as the transformers. So these are the basic parts of an X-ray machine. Thank you.